Welcome back to our episode on measurements and error analysis. Here's the question I left you with. Which clock maintains the Indian Standard Time? Cesium clock at National Physical Laboratory, New Delhi, clock tower in Shimla, clock at Jantar Mantar, New Delhi. And the answer is A. Cesium atomic clock is used at the National Physical Laboratory in New Delhi to maintain the Indian Standard Time. Did you measure up right to this question? Remember, at the beginning of the show, I asked you what gets measured at Jantar Mantar. Well, here's the answer. Jantar Mantar is a remarkable structure which consists of 14 geometric devices used for measuring time, forecasting weather changes, predicting planetary positions, and finding altitude of stars. All these devices are fixed structures and point in a specific direction. The largest device or instrument is the Samrat Jantar, which is 90 feet high, and its shadow is plotted in such a manner that it shows the exact time of the day. This dial has markings for every 15 minutes after 12 noon, and the time it is currently showing is between 3:45 and 4. By 6 in the evening, the entire dial will go into a shade. Measurement can sound very high on the theory quotient, so I'll not be surprised if you have a few questions. Let's look at some questions.
My name is Sarthak and I wanted to ask you the question that which unit is used to measure the distance between the Earth and the Sun?
Great question. Did you ever think about that? Which unit can be used to measure the distance between Earth and Sun? Since this distance is very large, the unit used to measure the distance between Earth and Sun is the astronomical unit, light year, or parsec. And here's a question that comes to you from our website, topperlearning.com. Can you think of a unit that is convenient to measure the size of a nucleus of an atom? The unit used to measure the size of a nucleus of an atom is Fermi, which is 10 to the power minus 15 meter. For more such facts, remember to log on to our website, topperlearning.com. Now we have seen measurements, different kinds of units to precisely measure the biggest to the smallest of the quantities. But how precise can precise measurements get? Are they actually totally precise and exact? They are not. It's now time to look at the errors in measurements. We have all done inaccurate measurements, measuring waistlines, heights, and body weight. Haven't we happily recorded measurements that we knew were not exact or accurate? Actually, there are errors in measurement that occur because of personal errors, or due to imperfection in experimental technique, or even because of the limitation of the measuring instrument itself. We'll use the most familiar apparatus for measurements from our daily lives, the ruler, to demonstrate this point. The smallest division of a ruler is 1 millimeter and can be used to measure the width of this box. It comes to approximately 1.1 centimeter. Note that the smallest measure of an instrument is called its least count. In case of a ruler, it will be 1 millimeter or 0.1 centimeter. There are instruments available with lower least counts. So here we have a vernier caliper. It typically has a least count of 0.01 centimeter. Let me measure the width of this box with this. So using the vernier calipers, the width of this box comes out to be 1.13 centimeter. Still better equipment is a screw gauge, whose least count is typically 0.001 centimeter. Let me measure the width using that. Measurement of the width of this box using screw gauge turns out to be 1.132 centimeter, which is much more accurate. So for a more accurate measurement, you need to use an instrument with a smaller least count and hence lesser error in measurement. Now look at an example where we calculate the error in the measurement to get an idea about the accuracy of the results. We'll discuss the absolute error, relative error, and percentage error. Here, we measure the period of oscillation of a simple pendulum by initially noting the time taken by the pendulum to complete 20 oscillations using a stopwatch. We repeat this at least 5 times. Each time, we find the average time taken to complete one oscillation. We realize that the successive measurements show a small variation. Let's now address a question from a student.
Hello ma'am, I am Akash. I want to know what are the different types of errors.
Figure this one out. What are the different types of errors here? They can be the absolute error and relative error or percentage error. Let's illustrate these different types of errors in this case of measurement of time period of a simple pendulum. The average time, T average, is the sum of period in each trial divided by the number of trials. And this turns out to be 2.624 seconds, which can be rounded off to 2.62 seconds. Let's call this the true value. It is the mean of all the measured values. The errors in each of the successive measurements are obtained by subtracting the true value from the measured value. We see that the difference between the two values can be positive or negative. The deviations obtained in each of the measured value with respect to the true value are called the absolute errors. Now we take arithmetic mean of all the absolute errors, where we take only the magnitudes of the errors and not the signs. That is, the delta T mean will be 0.01 plus 0.06 plus 0.20 plus 0.09 plus 0.18 second divided by 5, and this turns out to be 0.11 second. That means that the period of oscillation of the simple pendulum is 2.62 plus minus 0.11 second. That is, it lies between 2.62 plus 0.11 seconds and 2.62 minus 0.11 second, or between 2.73 seconds and 2.51 seconds. Here is a new term I want to introduce: fractional error. The fractional error is the ratio of the mean absolute error to the true value. It is also known as the relative error. The relative of fractional error, when expressed as percentage, is called percentage error. For this example, the relative error or the percentage error turns out to be delta A is equal to 0.1 divided by 2.6 times 100, which is 4%. And that brings us to the conclusion of the learning part of the show. If learning concludes, it must be time for exams, right? The class breaks for now, and we meet in a short while with the exam decoded section. Stay tuned.